My teammates and I wanted to design a project that would not only be based on scientific fundamentals, but that would also positively impact our planet. That's when we came up with the world's simplest food distribution system. The purpose of this project is to reduce food waste by creating a cold wire system that can transport canned goods to local food banks and shelters. With this system in place, people can give more with less effort.
The world's simplest food distribution system. We predicted that our coiled wire system would work, in comparison to how a train pulls its cargo. We wanted to see if the canned goods would be able to be transported using magnets, creating an easy and effective way to move them around.
The materials used for our science fair project were a wooden canvas, different colors of paint, various sizes of houses, plastic markers, Legos, a coiled wire, a battery, and magnets on either sides of it. This is a demonstration of our food distribution system. A battery with magnets on either sides of it will work as a mini train, and a canned food will be attached behind it. It will later be pushed through the coiled wire, and the magnetic field and the current will help propel the battery forward, making the food move. Now that the formation of the magnetic field is possible, we can place the battery within the coil wire and the battery will travel to the food bank within the range of a few seconds. As observed, the activation of the magnetic field pushed the battery along the wire, which allowed it to transport within seconds to the desired location.
The question that piqued our interest was inspired by the YouTube channel Amazing Science, who created a simple electric train only using a coil wire, a battery, and a magnet. By adopting the same method, they wanted to know if it was possible to apply the same concept in a different setting. The demonstration proved our hypothesis to be true. Now, this came about by using a wire in the shape of a coil as the electric conductor. By moving the magnet around the coil wire, this pushes the electrons and creates electrical current, thus creating the magnetic field. As demonstrated, two magnets were attached to the positive and negative ends of the battery. Now this makes everything connected to the coil, making the coil magnetic. These two magnetic fields cause the batteries to push through the wire at a fast rate.
After conducting the experiment with many trial and errors, as we concluded, our hypothesis was indeed true. We wanted to see if canned goods could be transported with magnets, creating an easy and effective way to move them around. The following procedures had to be taken into consideration. 1. The circumference of the coil wire must have a radius suitable for the batteries and magnets. This means that its radius cannot be too big or too small. 2. The thin insulated enamel coating helps the battery flow without friction. While doing the following procedures, we are able to successfully make this the world's simplest food distribution system. We hope that one day it will be possible to put our simple experiment into practice in the real world, especially in countries in need.